Hey Condors, it's your boy Mr. Roberts here with a little bit of social distancing science. Before we get to the agenda, don't forget to click subscribe and don't forget to mash that notification bell. Let's check out our agenda. We've got a few things we're doing today. We've got an investigation called Digging Deeper. Then we've got a little close reading about the incredible shrinking Mercury is active after all. We have an investigation on moons of the outer planets. And then we're going to read about what are the other objects in the solar system. We're going to do our lesson review for the solar system, and then you're going to do your LearnSmart for exploring the universe. So let's get started. So, digging deeper. What you're going to do is I want you to pick a planet, and then you're going to research the composition of the planet and its inner layers. So take notes about your planet, and then what you will do is the first question: what is your planet composed of? How is your planet structured? What surface features are present on your planet? Okay, you do not need to actually create a model of your planet, but if you'd like to, go ahead and email me a copy of that. Let's do a little reading about the incredible shrinking Mercury. Now, astronomers learn more about the terrestrial planets using space probes. What I want you to do is to read this passage and then reread the fourth paragraph. Underline the surface features that are present on Mercury. And then I want you to, like at dinner tonight, talk with your family about like what they know about surface features on Venus and Mars compared to Earth and Mercury. You can teach your family a little. So you're going to read this, you're going to do a little highlighting, and you're going to talk with someone. Okay, we're on to the investigation. Moons of the outer planets. What are the other objects in the solar system? Different types of objects orbit the sun. These objects include dwarf planets, asteroids, meteors, and comets. Unlike the sun, these objects don't emit light but only reflect the sun's light. What are the features, compositions, and locations of these objects? Let's investigate. So, did you know that Jupiter has 79 confirmed moons? Saturn has 53 named moons and 8 provisional moons. Uranus has 27 moons, while Neptune only has 13 named moons with 1 provisional moon. Why do you think the outer planets have so many moons compared to the inner planets? Now, the moons of the outer planets range in diameter from 2 kilometers to 5,200 kilometers. The largest moon in the solar system is Jupiter's Ganymede, which is larger than the planet Mercury. How can a moon be larger than a planet? Well, remember, to be classified as a moon, an object has to orbit a planet, not the sun. Okay, what I want you to do, so here we've got a little chart here. Select the largest moon from each outer planet. Then, from those largest moons from each planet, draw those moons in order from largest to smallest. Identify each moon and the planet it's come with. Create a scale so you can keep your drawings proportional. Be sure to show your scale. Now, can you research at least 1 or 2 of these identified moons? Compare and contrast a chosen characteristic. That could be surface features, composition, structure, distance from the planet for each of the moons that you want to look at. Okay, we've got to read about what are the other objects in the solar system. Moons. Many moons of the outer planets are small and have irregular shapes and unusual orbits. Some scientists think that they are captured asteroids, meaning the gravity of the planet pulled the object into its orbit. Captured asteroids are natural satellites, but they did not form by accretion as regular spherical moons probably did. Scientists classify some objects in the solar system as dwarf planets. A dwarf planet is a spherical object that orbits the sun. It is not a moon of another planet, and it is in a region of the solar system where there are many objects orbiting near it. But unlike a planet, a dwarf planet does not have more mass than objects in nearby orbits. Dwarf planets include Ceres, Eris, Pluto, and Makemake. Dwarf planets are made of rock and ice and are much smaller than Earth. Asteroids are chunks of rock and ice that never clump together like the rock and ice that form the inner planets. Some astronomers suggest that Jupiter's strong gravity may have caused the chunks to collide so violently that they broke apart instead of sticking together. This means that asteroids are objects left over from the formation of the solar system. Most are found in the asteroid belt between Mars and Jupiter. Comets are a mixture of rock, ice, and dust. The particles in a comet are loosely held together by the gravitational attraction between the particles. Comets orbit the sun in long elliptical orbits. Meteoroids, meteors, and meteorites. Meteoroids are small rocky particles that move through space. Most meteoroids are only about as big as a grain of sand. When meteoroids pass through Earth's atmosphere, they burn up because of friction and are seen as strikes of light in the sky. This is called a meteor. If a meteor doesn't completely burn up, it can impact the planet's surface. At that point, it's called a meteorite. And on to our lesson review for the solar system. Can you construct a graphic organizer that compares and contrasts objects in the solar system? Maybe even group objects by what are the differences between the nearer planets and the further out planets. Now, NASA has been sending exploration missions to Mars for almost 50 years. The length of time it has taken for the different spacecraft to reach Mars ranges from 150 to 360 days. In order to make it possible for humans to travel to Mars, the travel time must be reduced. Although, I don't know about you, but I've been sheltering in my house for, well, not 150 days yet, but it sure feels like it. Could you imagine being stuck in basically a small room with probably 3 or 4 other people for 150 to 360 days? Let me know about how you feel about that at the end of the summer. Now, assume that different spacecraft were using the same amount of fuel at the same rate. Why were there such long differences in travel time? Is it because the distance of Mars from the sun changes? Is it because the distance from Earth to Mars changes? Is it because the position of Earth from the sun changes? Or is it because the shape of the planet's orbit changes? Here's a chart that shows the surface temperatures of the outer planets. What can you conclude about the outer planets based on the data table? A. If Neptune were closer to the sun, it would be cooler. B. Saturn is closer to the sun than any of the other planets. C. The coldest planet is Uranus. Or D. The surface temperature of Earth is between that of Neptune and Jupiter. And our real-world connection. Think of other ways in which scientists observe, study, and explore space. What technology, other than the examples given to you in this lesson, has been added to everyday life because of space exploration? Okay, I'm not going to show you on the screen, but you also have a LearnSmart to do. Next week, we will be starting with family life. Hope you have a great weekend, and I will see you all later.